The next topic is the relation between observed oxidation state of lanthanides and their electronic configuration. Most of the stable and common oxidation state of lanthanides is +3. This tripositive oxidation state can readily attained by the loss of 6 electrons and 1 electron from 5d or 4f orbital. The first three ionization energies are very low. That's why most stable oxidation state of lanthanides is +3. They are highly electropositive and forms ionic compounds. So in this, generally the most stable oxidation state is +3, and these 3 electrons are lost by lanthanides from the 6 orbital. That is, 2 electrons are lost from 6s orbital and 1 electron is lost by lanthanides from the 5d or 4f orbitals. +3 oxidation state is more common and stable since the first three ionization energies are very low. That's why these oxidation states or +3 oxidation state of lanthanides is more stable, and that's why they are also called as highly electropositive elements and they can form ionic compounds. For example, cerium, samarium, terbium. In cerium, the ideal configuration is xenon 4f1 5d1 6s2. This is the ideal configuration, and observed configuration is xe 4f2 5d0 6s2, and the electronic configuration of Ln3 plus ion is, that is cerium 3 plus xenon 4f 1 5d0 6s0. This is the +3 ion electronic configuration of cerium. Then next is samarium. In this ideal configuration is xenon 4f5 5d1 6s2. Then observed electronic configuration is xenon 4f6 5d0 6s2. So in this, during the formation of samarium 3 plus ion, the 2 electrons from the 6s orbital and 1 electron from the 4f orbital will be lost by samarium and it will form samarium 3 plus ion. This is the stable oxidation state of samarium, cerium and all lanthanides. The next element is terbium. The ideal configuration is xenon 4f8 5d1 6s2 and the observed configuration is xenon 4f8 5d0 6s2. Again here, during the formation of terbium 3 plus, this terbium will lost 2 electrons from 6s orbital and 1 electron from 4f orbital, and that's why the lanthanum, that is lanthanum 3 plus, that is terbium 3 plus electronic configuration is xenon 4f 8 5d0 6s0. Then the next example is ytterbium. Again, the ideal configuration of ytterbium is xenon 4f again the ytterbium is having ideal configuration xenon 4f13 5d1 6s2, but observed configuration is xenon 4f14 5d0 6s2, and during the formation of ytterbium 3 plus ion it will lose 2 electrons from the 6s orbital and 1 electron from the 4f orbital. That's why the electronic configuration of ytterbium 3 plus ion is xenon 4f13 5d0 6s0. So in this way, there is a stability will be attained by lanthanides by shifting electrons from d orbital to the f orbital, and finally they will lose 2 electrons from the 6s orbital and 1 electron from the 4f orbital, or we can say that from the 5d orbital. From the above table, it is clear that the lanthanide exhibits its tripositive oxidation state. Some lanthanides exhibit +2 and +4 oxidation states, but these states are less stable and are called as anomalous oxidation states. So apart from that, some lanthanides exhibit +2 and +4 oxidation states also, but they are also called as anomalous oxidation states. Anomalous oxidation states are generally less stable, but some elements or some lanthanides will be stabilized these oxidation states by attending stable empty half filled and completely filled electronic configuration of F0, F7, F14 respectively. So in this way there is a relation between observed oxidation state of lanthanides and their इलेक्ट्रॉनिक कॉन्फ़िगरेशन. सो जनरली हमको ये पता है कि अगर हमारे पास ऐसा कोई एलिमेंट है जिसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन एक तो एम्प्टी है या फुलफिल्ड है या कम्प्लीटली हाफ फिल्ड है, जैसे कि F0 दिस इज़ द एम्प्टी इलेक्ट्रॉनिक कॉन्फ़िगरेशन, उसमें एक भी इलेक्ट्रॉन अवेलेबल नहीं, इसलिए उसको बोलेंगे हम एम्प्टी. उसके बाद F7 में क्या होता है, जनरली हम बोलते हैं F ऑर्बिटल कितने होते हैं, 7 होते हैं, तो उसमें हर एक ऑर्बिटल में एक इलेक्ट्रॉन है, इसका मतलब इट इज half filled electronic configuration. Then F14 all orbitals are completely filled, each having 2 electrons, that's why this is called as completely filled electronic configuration. अगर ऐसा होता है तो इसकी स्टेबिलिटी क्या होती है, सबसे ज़्यादा होती है. इसीलिए कभी कभी क्या होता है, बहुत सारे ऐसे एलिमेंट्स होते हैं कि जनरली एनामलस ऑक्सीडेशन स्टेट होने के बावजूद उनकी स्टेबिलिटी बहुत ज़्यादा होती है ड्यू टू द stability of empty, half filled and completely filled orbitals. Okay, so in this way we have discussed relation between observed oxidation state of lanthanides and their electronic configuration. The next topic is position of lanthanides and actinides in periodic table. Generally lanthanide series, that is 4F block having 14 elements from cerium, atomic number is 52, to lutetium, that is atomic number Z is equal to 71. Since period follows lanthanum, that is atomic number 57 in periodic table, they are called as lanthanide or lanthanums. Okay, so जनरली क्या होता है पीरियोडिक टेबल में, जो भी आपके लैंथेनाइड्स हैं एलिमेंट जो है वो आते हैं लैंथेनम के बाद, ठीक है, तो इसलिए उनको क्या बोलते हैं हम, लैंथेनाइड सीरीज. और जो भी एक्टिनाइड सीरीज के एलिमेंट हैं वो आते हैं पीरियोडिक टेबल में, दैट इज इन 5th पीरियड, किसके बाद आते हैं, एक्टिनियम के बाद आते हैं, इसलिए उनको क्या बोलते हैं, एक्टिनाइड्स बोलते हैं. ओके, सो द नेक्स्ट पॉइंट इज लैंथेनाइड्स कैरेक्टराइज्ड बाय preferentially filling of 4F orbitals. The elements of lanthanides very closely in the physical properties, hence their position in periodic table has become a serious problem. But for our convenience and better understanding of lanthanides, they are listed separately in horizontal row below the periodic table. Thus lanthanides occupy anomalous or unusual position in the periodic table. Actinide series having the 14 elements from thorium, atomic number 90, to lawrencium, atomic number 103. Since these elements follows actinium in periodic table, they are called as actinides or since these elements follow actinium in periodic table, they are called as actinides. So the next point is the elements of actinides characterized by preferentially filling of 5f orbital as the last electron enter in 5f orbital. It is also called as 5f block elements. Elements of actinide shown in the seventh period as placed in the horizontal row below the main periodic table. So in this way we can understand in lanthanides the last electron is entering in the 4f orbital and in actinides the last electron is entering in the 5f orbitals. Generally actinides generally elements of actinides shown in the 7th period as placed in the horizontal row below the main periodic table.